Blessed love to everyone, to all of our students, to all of our young scholars. Welcome to this, our 28th class. This is our 28th class of astronomy. For all those in the Group K section, this is our 28th class. We have come so far, thus far. We have learned so much in that time, and I'm very happy to know that you have been learning a lot. Those of you who have been corresponding with us and showing that appreciation for all the knowledge and information that we bring to you every day, our astronomy class, and of course, our African history heritage class. Yesterday, our African heritage class, I know it was a bit touching for a lot of you your young minds, pardon me. You know, we've been talking about the glory of Africa. We've been going into the pyramids and the Lalibela and Aksum and the River Nile and the Kingdom of Kush. But yesterday, for the first time, we spoke about, what did we speak about yesterday?
Yesterday we spoke about for astronomy.
No, for African
Oh,
heritage and
we spoke
history.
about slavery.
We were speaking about slavery and how hard it was for us. So you young souls, you young children that are taking in this African history and heritage and this astronomy course, just know that a lot of the information we're giving to you, they're not going to teach it to you in the regular schools. In fact, they feel that you're too young for this. But no, this is the time that you need to know your African heritage. This is the time you need to know your African history and to know about the cosmos that is around you. So we're going to continue today in our journey amongst the stars. We've done so much already. We have touched the sun. We have gone into all the planets. We've even dealt with some of their moons, which we will return to, especially when we go to another level. And now we are on the stars. We have already spoken about the nebulas. We've spoken about supernova, of which we're going to return to today. We're going to go a little deeper into the supernova. And we also spoke of the quasar and the black hole. So there's so much information that we have already shared, videos. And again, I'm very happy that you and your parents have chosen to bring Priest Isaac's Institute of Holistic Knowledge into your home on a daily level. And I just felt I had to say thank you, or as the princess has been teaching us in our Kiswahili, Asante Sana. So blessed love, Princess Akisha Menin.
Blessed love.
Blessed love, Prince Alamase.
Blessed love.
We are definitely going into next level today. Let us just even begin right here. We're going to read some information. This is coming from the website sciencekids.co.nz. And remember, we change kids into children here. You bring us any kids, we bring you back some children, you know.
Kids are young goats.
Kids are young goats. We bring you back some youth. So, young ones, we're going to do a little quick, this is somewhat of a quick revision because we somewhat went through this information maybe on some other websites or through the encyclopedia and the videos that we brought forward. So basically, a star is a massive bright sphere of hot gas called plasma, which is held together by its own gravity. So, young ones, if someone is to ask you, what is really a star? Now, this is not twinkle, twinkle, little star. This is much more higher as far as information, and you're not too young, whether you're 3 years old or 33 years old. You're never too young or too old to learn. So a star is a massive bright sphere of hot gas called plasma, which is held together by its own gravity. Okay? All right, another point about the star.
Stars radiate energy created from a nuclear fusion, which is a process that takes place in a star's core and involves hydrogen fusing or burning to make helium.
That's it.
Mhm.
Nuclear fusion. We spoke of nuclear fusion when we were doing the sun. You want to tell us a little bit about nuclear fusion?
Of course, nuclear fusion is when two hydrogen atoms form together to make one hydrogen.
Mm. And this is what happens to create as I said, the star. The stars radiate energy created by the nuclear fusion that the young prince just explained to us, which is a process that takes place in a star's core and involves hydrogen fusing, burning to make helium. All right, just a little more information on the star.
As a star is near the end of its life, it begins to change the helium into heavier chemicals such as carbon and oxygen, and the star will begin to change color, density, mass, and size.
I think now this is almost like a review that we are doing, because we also went into that. As the star is near the end of its life, it begins to change the helium into the heavier chemical elements such as carbon and oxygen, and the star will begin to change color, density, how packed together it is, mass, what it's made up of, and of course its size. All right.
The nearest star to the Earth is the Sun, which is classified as a G2 yellow dwarf star.
So our own sun that you see in the firmament, the nearest star to the earth, that is it. And it is classified, for your knowledge now, as a G2 yellow dwarf star. Very important. And now you want to read this one here for me, Honorable Prince.
Mhm.
After the Sun in our solar system, the nearest star to Earth is Proxima Centauri. It is about 39.9 trillion kilometers away from, or 4.2 light years. This means it takes light from this star 4.2 years to reach the Earth. Using the newest, fastest space probe, propulsion, systems would still take a craft about 75,000 years to get.
Oh, wonderful. Very good, my Lord. Wonderful, wonderful. So as you could see, the closest star to Earth is still so far away. It is 4.2 light years away.
After the Sun is gone.
Well, outside of the sun.
Yeah,
very good.
outside of the Sun.
Because the sun is 90. Anybody can remember how far away the sun is from Earth? What about here? Anyone can remember? Let me hear it.
93 million miles away.
93 million miles away. And the closest star outside of that is 4.2, not miles away, light years away. Because a light year is the distance that the light travels in a year. And in a second, light travels 186,000 miles in a second.
That's fast.
That's fast, in 1 second. So that's how far light goes just in a moment's time. So you can imagine how far it goes in a minute, in an hour, in a day, in a week, in a month, in a year. 4.2 years, and that's the closest star to the Earth, beside or outside of the sun. All right. So what I would like to do with you today, I want to okay, here we are. We're looking at this is from the NASA website. spaceplace.nasa.gov website. And we're just going to take some information here as it relates to the supernova.
What is a supernova?
Mhm.
A supernova is the biggest explosion that humans have ever seen. Each blast is the extremely light, super powerful explosion of a star.
Extremely bright. Well, bright is light.
Yeah.
Extremely bright. So as the young princess said, so that's the question. What is a supernova?
And that's the short answer.
A very short answer. A supernova is the biggest explosion that humans ever seen, have ever seen. Pardon me, please. Each blast is extremely bright. Super powerful explosion is extremely bright. Super powerful explosion of a star. Each blast is the extremely bright, super powerful explosion of a star. A supernova is the biggest explosion. Okay, that's exactly what we read there. That's the short answer. So this is basically
A supernova?
yeah, a rendition of the supernova.
Looks like a
Because remember, the supernova is actually the star itself exploding. And of course, the light and that explosion itself, the brightness itself, as you see under here, an illustration. An illustration, and an illustration basically means a picture of, to show what it would look like. An illustration of one of the brightest and most energetic supernova explosions ever recorded. Now there it is. And that is the star exploding and all the energy from underneath the surface of the star coming out. Okay, so it says here, what causes a supernova? One type of supernova is caused by the last hurrah, or a dying massive star. This is not necessarily an astronomical term. It is just a phrase that people use, the last hurrah. So one type of supernova is caused by the last hurrah of the dying massive star. This happens when a star, at least 5 times the mass of our sun, goes out with a fantastic bang. All right. Massive stars burn huge amount of nuclear fuel at their cores or centers. This produces tons of energy. You have hiccup?
No.
Oh, okay, sorry. So the center gets very hot. Heat generates pressure, and the pressure creates, and the pressure created by a star's nuclear burning also keeps that star from collapsing. So, what is that really saying?
What you just said.
Yeah, I mean, what a lot of talk, yeah? Yeah. So basically what it's saying really is that you have these stars, these massive stars. Remember, huh? A star is a lot of energy. That's really the point. Just like our sun, remember, it is our sun that gives us the life that we have, in the sense of whatever you see happening on Earth, whether it's photosynthesis, evaporation, condensation, breathing, just the fact that light itself can travel in an atmosphere, the atmosphere that is created around planet Earth, just life in general, the creation of it and the sustenance of it has a lot to do with our central star, which is the sun. And also its energy is shared to all the other objects, like the planets, Venus, Mercury, Jupiter. We have visited all of these planets already. Eh? All of them have their connection to the sun. And the sun is its own dynamo as well. So that means the sun, the point I'm making is the sun has a lot of energy. Just to do all of this work, if the sun was to lock off tomorrow, listen to me, little ones, if the sun was to disappear, that's it. The solar system would stop moving, everything would stop working. No more TV, everything gone. Eh? You can't even go on skateboard, ride your bike, nothing. Everything has changed. You saying something?
The light would take 88 minutes to leave.
Yes, the light of the sun takes 8 minutes really from the sun to the earth. So the fact that the sun has all of that energy and it's one of the smallest stars that we know of, you imagine these big, 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 big. That's why they have to be so far away. That's why they have to be 4 light years away, and 10 light years away, and 100 light years away, and 1,000 light years away, because you don't want these stars to blow up in your neighborhood. Even 4 light years away is a little too close for an explosion. That's how powerful the explosion of a massive star is. Because remember, as it says, it has nuclear fuel at its core. And so when it gets very hot with all of this tons of energy, it will just go bang and explode. Can you read this for me, Prince?
A star is in balance between two opposite forces. The star's gravity tries to squeeze the star into the smallest, tightest ball possible. But the nuclear fuel burning in the star's core creates strong outward pressure. This outward push resists in the inward squeeze of gravity.
Yes, and you know, and a lot of what the young Olmec was saying there can be seen here. You know, this is basically an Honorable Princess, what holds the star together, the gravity from without.
And this is what's happening to you too. Gravity is pushing you, and inside of your body, there are some outside forces coming against gravity.
Natural. Okay, that sounds real positive to me. And the same thing, because we are the earth and we are the stars and everything thereof. So it says here, what holds stars together is a balance of gravity pushing in on the star and the heat and pressure pushing outward from the star's core.
When a massive star runs out of fuel, it cools off. This causes the pressure to drop.
Okay, hold on. Before you get what the princess is saying. Read that again, princess, please.
When a massive star runs out of fuel, it cools off. This causes the pressure to drop.
Read that now.
Gravity wins out, and the star suddenly collapses. Imagine something 1 million times the mass of Earth collapsing in 15 seconds.
Imagine something 1 million times the mass of the Earth collapsing in 15 seconds. You have ever experienced an earthquake? Imagine the Earth collapsing in 15 seconds. Much more something 1 million times the mass of the Earth.
The collapse happens so quickly that it creates enormous shock waves that cause the outer part of the star to explode.
That's exactly what happens there. So, hence the supernova, because of the pressure and the power and all the nuclear energy inside of this star. And yet still, it may seem like, yeah, it runs out of fuel and it cools off, but it collapses in such a short time, within seconds, bang, a supernova is formed. Usually, a very dense core is left behind. Remember, dense means well compressed and packed together. That is why, as we said in a previous class, that on a neutron star, a teaspoon of a neutron star could weigh as much as several elephants. You know, so usually a dense you find that funny, yeah? Usually a dense core is left behind, along with an expanding cloud of hot gas called a nebula. Which, you know, as we said, nebula comes from maybe the word cloud. A supernova of a star more than about 10 times the size of our sun may leave behind the densest object in the universe, which is obviously the black hole. And you're looking at the star, the Crab Nebula there, and this is showing you how the black hole itself would be formed even from the supernova.
And by the way, nothing can escape black holes, not even light.
Not even light, because the electromagnetic energy is so strong that it would suck all the space debris, even down to light itself, even into the black hole.
But don't worry, the closest black hole to Earth is 4.5 light years away.
4.5. That is not too far from the star itself. And keeping in mind that within our galaxy, at the center of the galaxy, there is a super massive black hole at the center of the galaxy. So what we are going to do, and of course, you know, tomorrow we will say.
What I'm saying is that after 5 billion years, the sun will become a supernova itself.
Our sun will be no more in approximately 5 billion years. That is what science says. In fact, science is saying that our sun is halfway through its life. It's at its peak time now. So the princess is saying that in about 5 billion years, you know, it's a long time. You have time. You could go shopping and come back. You have time, you know. But it will happen, you know. So if people are going to continue to have children and life will continue, it is something to look forward to. Yes, give thanks for that. So the dynamics of the stars and the sun is very, very, very heavy, I must say. But anyway, as I said, tomorrow, of course, looking forward to seeing you again for another classroom session in this our international homeschool session. And of course, you know, tomorrow is African History / Heritage, and we will continue to cultivate the minds of the young ones and all you old ones that are part of the course. It's all right. Don't be ashamed. That's good. You know, it is a part of the growing. And remember these classes and videos that we send to you every day. If you're one of those big ones, you know, that you could save for when the little ones do come, because the information is really priceless. So yes, this was our 28th astronomy class, and of course tomorrow will be our 28th no, it will be our 28th African Heritage and History class, and of course, you know, this is our K group, what they refer to as kindergarten. But I know a lot of you in the class, you're above kindergarten age, but that doesn't make a difference. It's the knowledge. If you are a novice to this is good information. And for you, whether you're 3 years, 4 years, 5 years, whatever, don't worry. This knowledge is good information. When you meet your friends at the playground and you can tell them about Proxima Centauri and tell them that it's 4.2 light years away, it'll be like, oh, okay, what have you been eating? So give thanks. Anyway, remember to go over the video and go through all the notes that you've kept. And those who have any outstanding project, please send them in. As we always say here at the Priest Isaacs Institute of Holistic Knowledge, I am the best, and I deserve the best, and only the best is coming to me now. Give thanks. Holy Manuel Eyes,
Selassie Jah Rastafari.
Blessed love.